Imagine stepping outside tonight. You look up, expecting the familiar pinpricks of stars against an inky black canvas, but instead, a breathtaking, colossal arc of light stretches from one horizon to the other. It's not a rainbow, it's not the Milky Way, it is a magnificent system of rings encircling our own planet. This celestial feature would dominate our sky, a constant reminder of our place in the cosmos. It would change everything we know about day and night, transforming our sky from a simple window into a dynamic, ever-present spectacle of cosmic proportions. This isn't science fiction, it's a thought experiment grounded in real physics. What would our world be like under this cosmic halo? The appearance of these rings would be a dramatic and varied experience, depending entirely on where you stood on the globe. For those living near the equator, Quito, Ecuador, Nairobi, Kenya, the rings would appear as a razor-thin, brilliant line, rising straight up from the eastern and western horizons and bisecting the sky directly overhead. It would look like a celestial highway, a silver thread stretched taut across the heavens. During the day, this line would be a bright, shimmering ribbon. At night, it would glow with reflected sunlight, outshining even the fullest moon and casting a soft, ethereal light upon the landscape below. Now let's travel north or south to the mid-latitudes. Paris, Tokyo, New York City. From these vantage points, the rings would no longer be a thin line. Instead, they would manifest as a majestic, wide arc that permanently graces the sky. This shimmering band would rise from the horizon at an angle, dominating a significant portion of the celestial dome. Its appearance would shift with the seasons. During the winter, the sun would illuminate the rings from below, making their undersides glow brightly in the night sky. In the summer, their topside would be illuminated, casting a vast, moving shadow over the earth, and creating spectacular, prolonged twilights that would last for hours. What about the polar regions? For observers standing near the Arctic Circle and Antarctic Circle, the rings would look completely different yet again. They would appear as a low, shimmering wall, or a bright hump on the horizon. The full grandeur of the arc would be lost from this perspective. Instead, it would look like a distant, luminous mountain range that never moves. The constant daylight of polar summers and the perpetual darkness of polar winters would be profoundly affected. The rings would block a portion of the precious sunlight during the summer, while in the winter, their reflected glow would create a permanent, ghostly twilight, banishing true darkness from the polar nights for good. So, how could our planet even acquire such a spectacular feature? It's not as far-fetched as you might think. We have a cosmic precedent right in our own solar system. Saturn, Uranus, Neptune, Jupiter. The most likely scenario for Earth involves something we call the Roche limit. This is a critical distance from a planet. It's where the planet's tidal forces overcome the gravity holding a smaller body together. If a moon were to wander inside that limit, Earth would tear it apart. If a large asteroid drifted in, it would be shredded. If a comet crossed that line, the same fate, broken into countless fragments of rock and ice. Those fragments wouldn't just plunge down. They'd spread into a wide, flat disk, trapped in orbit around Earth's equator. Over millions of years, collisions would sort and flatten that disk into distinct, stable rings. A beautiful, violent cosmic ballet. Another route, a catastrophic impact. Imagine a Mars-sized object hitting early Earth. The same kind of collision that likely formed our moon. A smaller but still massive impact could fling debris into orbit that coalesces into rings. Once formed, the rings would be dynamic, not static. Unlike Saturn's icy rings, Earth's rings would be rocky and silicate-rich. Upper atmosphere drag would slowly rob particles of energy. The sun's and moon's gravity would also perturb their orbits. Over millions of years, they'd spiral inward and burn up as a persistent meteor shower. So, while glorious, our cosmic crown would be fleeting.